Welcome. This video covers linear associations between numeric variables in SAS. We've already talked about how to summarize a single numeric variable. What this video focuses on is if I have two numeric variables, what other summaries might I care about for those? And the main thing that we do in statistics generally is we try to summarize the linear relationship between those variables. You could of course do a lot of complicated things, but the sort of most basic thing to do is look at that linear relationship. There are two statistics that we look at for that, covariance and correlation. Now, to get these things out in SAS, there's a PROC for it. So PROC CORR is going to allow us to find correlations and covariances between variables. Here's the basic syntax, PROC CORR statement. There's going to be some options on that we'll look at in a second. Just like before, you can use a by statement if you want to do this by different variables. But then you just specify which variables you want to look at the linear relationship between in the var statement. Here are some of the statement options that we might care about. And again, note how we specify the options. They come directly after the PROC CORR statement before our semicolon. But some of the things that we'll look at here would be cov. So cov allows us to compute the covariance. We'll just put cov directly after that. Of course, we use our data equal option as well. And then we'll utilize the Spearman as well. This is a different way to calculate correlation that works better when you have outliers in your data set. And we'll need a data set to analyze here. So we'll go back to that Titanic data set that we read in previously. We're going to request the covariance up here by using the COV option. And then we're going to specify the variables that we want to calculate the correlations and covariances of in the var statement. You might notice here that we are using the survived variable, which was 0 and 1. It's okay to include a binary variable in correlations. It doesn't quite have the same interpretability, but it's okay. And then P class, this was a variable that took on, I think, 1, 2, and 3. But it is what we would refer to as an ordinal variable. So 1 is better than 2 is better than 3 in this case, I believe. And you can do correlations on that, although you need to be a little bit careful whether the difference between 1 and 2 is the same as the difference between 2 and 3 and things like that. But we'll be able to go ahead and look at those correlations anyway. So first, the output from that cov option is given here on the left. So you can see here the covariance between age and fair is highlighted. Covariance is a measure of the covariability and the linear relationship between these two variables, but it has units on it, and so that makes it very difficult to interpret. Instead of looking at covariance, almost always we look at correlation. And so over here, we'll see the output for that. We can see the correlation for age between age and fair here is highlighted. So we have a correlation of about 0.18. So this would be a low correlation, but there is possibly some linear relationship between age and fair, although that relationship is probably not that strong. Again, you can look at this sort of basic correlation that automatically gets produced. That's called Pearson's correlation, and that uses the actual data values to calculate the correlation. If you have lots of outliers or things like that floating around, you can use Spearman's correlation instead, which uses the ranks, the relative ranks of the data, rather than the actual data values themselves. And this just helps to deal with those sort of extreme values. How we ask for Spearman instead of the default is we're just going to add the Spearman option up here on our PROC CORR statement. And you can see that this correlation value did change. It was about 0.178 before, now it's 0.192. So we do get a little bit of a change here, but you can still interpret this in the same way as before. There's still a weak positive linear relationship between these two variables. All right, let's jump into SAS and do a quick example there. All right, here we are in SAS. We'll go ahead and do some correlation analyses using PROC CORR. So we'll use that online news data set that we read in before. So we'll do data equal ncsu.mynews. And we won't ask for covariance or Spearman or anything. We'll just use the default. And you don't have to specify a var statement. If you don't, it will try to compute the correlations between all of the numeric variables in your data set. If we try to do that here, that would be a whole lot of output. So we don't want to do that. We definitely want to include a var statement and specify the variables to look at. So in this case, of course, shares is one variable that we care a lot about. But another one that we might care about would be perhaps the negative and positive ratings of these articles. So we could try to look at the correlation between the number of shares and how negative or positive the article is. So we'll include, if I can spell, polarity and average positive polarity. Let's go ahead and run this code, see what happens. Checking our log. Looks like I maybe spelled one of these wrong. Yep, positive. Fix that. We'll rerun. Still spelled it wrong. Let's go back. Yep, put that I in the wrong spot. All right, let's rerun that. And here we go. We now have a matrix specifying the different correlations here. So there does not appear to be much of a relationship, although this is statistically significant. That might be just due to our very large sample size here. But we have a very, very weak negative relationship between shares and negativeness of the article, and a very, very weak positive relationship between positive nature of an article and the shares. So it's good to know that maybe that is not super important in terms of getting shares. All right, we now know how to summarize our numeric variables. If we have one variable, we can summarize the center and spread. If we have multiple numeric variables, we can look at the linear relationships through correlation. We can also do these same things at every level of a categorical variable using class or by. So that's great news. Next up, we'll start to look at these things graphically instead of numerically.